Hi everyone, so today we're going to be doing Hooke's law. And Hooke's law tells us that the force exerted by a spring when you stretch or compress it is equal to negative K, which is the spring constant, times that distance by which it's stretched or compressed. So the spring constant K is what we're going to be looking for in this lab, and it tells us how much force is required to stretch or compress a spring by a certain amount, by a certain distance x. So now we have to talk about this negative, which comes from the fact that this is an opposing force. So if I stretch a spring, the force exerted by the spring is going to try and pull it back into its original equilibrium position. Likewise, if I compress the spring, it's going to push back on me and try to do the same thing. So that's where the negative comes in. And we don't really want to deal with that in this lab, so we'll make a note of this free body diagram, which tells us that the force exerted by the spring is equal and opposite to the weight of the mass applied. So we're going to apply mass to the spring, and that Fg equal to mg is equal and opposite to the force of the spring. So we can say that Fs equals negative Fg, which means that Fg is equal to positive Kx from this. So that gets rid of the negative. And then we're going to be using Fg to make our data tables, and Chip's going to show us.
Okay, so we're going to do a simple experiment, add some force to our spring, measure the stretch that force gave the spring, and we're going to plot that data. So first we need to get the initial length of our spring. I'm going to use the bottom of this hook to reference my length point. So the initial length is 40.5 centimeters. Okay, so I'm going to add 100 grams to our spring. That's equal to 0.98 newtons. So now, spring length is 45.8. So if I do 45.8 minus the initial length of 40.5, that is 5.3 centimeters. So 0.98 newtons stretched our spring 5.3 centimeters. So I'm going to add another 100 grams. So now we have a total of 200 grams, or 1.96 newtons. And now the length is 51.8. So 51.8 minus the initial is 11.3 centimeters. Okay, so I'm going to add a third 100 gram mass. So we have 300 total grams. Now there's 2.94 newtons on our spring. And it's 57.8. So 57.8 centimeters minus 40.5, which is the initial. That's 17.3 centimeters. Okay, so we're just going to use Hooke's law. We have forces, we have x's. So if we plot force on the y-axis and x on the x-axis, we'll be plotting this line, and our slope should be k. So what you guys need to do is find some resource that will give you the slope of a line. So you're going to plug in these data points, find the slope of the line, and that will be k. And don't forget to tell us the units.